let's start by writing the homework for tonight. So it's absolute value functions. It'll be 3-2 homework. Number 1 through 6. Due Friday. Okay? Due tomorrow. Alright, homework 1 through 6. And then let's go ahead and go to 3-2. We're going to graph absolute value functions. Alright. Excuse me. So the absolute value function, we've solved those. We haven't talked about what their graph looks like though. So that's what we're going to do today. The absolute value function is written as f of x equals the absolute value of x. So when we take the absolute value, if we were to put it in a xy chart, xy, because this is y equals the absolute value of x, same thing. We're going to complete the table, graph it, and then we'll talk about what the graph looks like. And they all follow the same kind of shape. So if I were to take -3 and take the absolute value of -3, I get 3. If I have -2 and I take the absolute value, I have 2. Then I have 1. The absolute value of 0 is 0. And then obviously 1, 2, 3. Okay? So when I go and plot these points on my xy coordinate plane, aka my graph, let's see what happens. So I'll go to -3, 3, -2, 2, -1, 1, 0, 0, and then 1, 1, 2, 2, 3, 3. Okay? And when you connect the points, please don't forget to do that. That's your absolute value function. Obviously these go on forever, but I'm really not going to write those arrows every time. It's okay if you don't. Okay, so the domain is all real numbers. One side of the graph goes all the way left, one side goes all the way right. So for all of these, the domain should be all real numbers. Okay, there's no break in the x. Left and right forever. Then our range is going to be, for this one, there's a clear value y hits, and then it goes up from there. So that's a y is greater than 0. Greater than equal to 0, sorry. Definitely include that point. There's no open circle there at all. So the range will change based on the y. Could be greater than, could be less than. We'll see. Okay? So the graph looks like a V. Excuse me. And the turning point is called the vertex. Okay, so there's a couple cool things about the vertex here. Well, one cool thing is it's either the minimum or the maximum. It's either the lowest point or it's the highest point. And the graph is symmetric on either side. So if I look at the vertex in my table here, on either side of it, I get the same value. 1 away, I get 1. 2 away, I get 2. 3 away, I get 3. And then, like, if I folded this line here, it would be the same on both sides. That's called symmetry. And so, the graph is symmetric on either side of the vertex. So that's kind of cool. Something special about this graph. So to graph by tables, we're going to go through and do the odds here. I don't think you need to see 8 examples. So we'll do the odds. Let's go through what we're going to do. To create a table of values, it's best to place the vertex in the middle. Then we'll include values on both sides. I'll show you why for example 2. Okay, so let's say we have something crazy like a big number. And let's say the graph goes like this. And the vertex is at 3, 4, 5, 6. 5, 6, 5. That's my vertex. Okay, so if I centered the table around 6, 5, I would get some numbers on the other side of 6 And then I would graph my function, and it would look like this, okay? But what would happen if I didn't center my table around 6? Like, what if I stopped at 6, or if I even stopped at 5, and I didn't have any of the rest of the table? That wouldn't help me out, because if I went and plotted these points, I'd just get a line forever. Like, if I went from 5, 4, 3, 2, 1, 0, all the way to the negatives, it would just look like this. And that doesn't help us. When it's an absolute value graph, we've got to have both sides, okay? So that's why you really need to center the vertex in the middle and place your value, or the rest of your table, around this value, okay? So to find the x value of the vertex, we're going to set the expression in the inside of the absolute value equal to 0, okay? That's just whatever's in here, we'll set it equal to 0 and solve for x. That is just a property of a vertex that works for every single function. Okay, so like for 1, let's find the vertex, and then I want you to box the middle of your table. So we'll look at 3 above the vertex and 3 below the vertex, and that's what I want you to do. So that means center your table around the vertex. The vertex goes here. Okay, so we're going to set the inside x minus 4 equal to 0 and solve for it. X equals 4. That's going to be our vertex. Okay? And of course that's going to be 0 when we plug it in, because we just set it equal to 0. So 4, 0. But just in case, we'll go through that. Okay, then for the function, I'm going to actually write the absolute value of x minus 4 so I can see it again. Okay, so I'm going to center the table around 4. What does that mean? That means I'm going to go 1 above 4 each time, 4, 5, 6, 7, and then 1 below 4 each time, 3, 2, 1. So this you're going to go up by 1 each time, and then on the other side you're going to subtract 1 each time, and that's what we call centering a table around a value. Okay? So each one I'm going to plug into the function. So I'll have 1 minus 4, that'll be negative 3, and then I absolute value it, that's 3. Okay, then I'll plug in 2. 2 minus 4 would give me negative 2. So absolute value that, 2. 3 minus 4 is negative 1. Absolute value that, 1. Okay? Then if I plug in 4 minus 4 is 0. Okay, then 5. 5 minus 4, that absolute value is 1. 6 minus 4 is 2, and 7 is 3. Okay? So on either side of 0, I should be having the same values. That's called symmetry. If you don't, you probably either did your table wrong or you did your calculations wrong. Okay, so use that as a way to check yourself. Let's graph this. I'm going to go to 1, 3, 2, 2, 3, 1, 4, 0, and then 5, 1, 6, 2, 7, 3. Okay, and I get absolute value. Just going to connect them as best I can, and that's it. Alright, domain is all real, and now range, I have, oh, this is the same. 0 is the lowest y value. Sorry, that was bad. 0. And it goes up from there. So y is greater than or equal to 0. Okay? Alright, let's go to the next page. We'll just do the odds. I think you'll get it with just that. Alright, number 3. We need to center our graph around the vertex, which you do by setting the inside equal to 0. Okay, so this is actually really easy. X is the inside, that equals 0, so that's going to be my vertex. Okay, so I'm going to center it around that. I'm going to go up 1 each time here, so 1, 2, 3. And I'm going to go down 1 each time here, so negative 1, negative 2, negative 3. Okay, then I'm going to plug it into the function, It really couldn't be any more straightforward than this. Alright, so I'm going to plug in -3 to x and get 3. The absolute value of -3 is 3. 3 plus 5 is 8. Then I'll do the absolute value of -2 is 2. 2 plus 5 is 7. The absolute value of -1 is 1. 1 plus 5 is 6. Okay, now this one, when I plug in 0, I get 5. I don't get 0 out. I get 5. Okay, and then 1, 6, 2, 7, 3, 8. Alright, let's graph it. Okay, so 0, 5. Oh, it's going to go off the graph quickly. That's okay. Then we have 1, 6, 2, 7, 3, 8. Oh, it did it. Okay, nice. And then we go on the other side. So -1, 6, -2, 7, and -3, 8. Alright. There we go. That's the absolute value. Okay? So it just kind of took the regular absolute value function we did on the front page and moved it up 5. So our domain is all real. Range is y is greater than or equal to 5 is that lowest value there. Okay? Alright. I know I said we were going to do the odds, but let's do 4 because there's a fraction. So I think I want to talk about that one. Alright, so let's go through the same process. We'll find the vertex first. So let's set the inside 1/2 x plus 1 equal to 0, and we'll solve that vertex. Solve for x. So 1/2 x equals -1, and when I times by 2, x equals -2, okay? So I'm going to center my graph around -2, but when I plug stuff in, I'm probably going to get some fractions out, okay, because I'm timesing it by 1/2. Alright, so here's my vertex. We'll go up by 1, then we'll go down by 1. So I have -1, 0, 1, and then -3, -4, -5. Okay, and then obviously the graph goes on both ways forever. We're just doing enough points so that we get enough to fill up this graph. Okay, so I'm going to plug in -5. -5 times 1/2 is -2.5. Plus 1 is -1.5. Then when I subtract 4, see, we're going to get some decimals here, okay? Let me just double check. So -2.5. So if you happen to do this on your own and you got -5.5, you forgot to take the absolute value. Got to do that first, okay? So it would be 1.5 minus 4, -2.5. Alright, when I plug in 4, I'll get 1/2 times -4, then plus 1. Absolute value of that minus 4 is -3. Okay? Then -3, I'll do 1/2 times -3 plus 1, then I'll subtract 4. And get -3.5. Okay? Then for -2, that should be -4. And if you do this out, we should get the same thing on both sides. Okay? So, at those half points, you're obviously just going to put the point halfway between the boxes that you see. Okay, so let's graph them. -5, 2.5. Let me get a different color in case they overlap with what I wrote. So -1, 2, 3, 4, 5. -2, and then 1/2 a box there. Okay? Doesn't have to be perfect, but close enough. Then -4, -3, negative 3, negative 3.5, negative 2, negative 4, okay, and then negative 1, negative 3.5, now it's coming back up, so we were at the vertex, 0, negative 3, and then 1, negative 2.5, okay, so that's enough. It's going to go off to the same kind of angle both sides. Alright, that doesn't look perfect, but yours doesn't have to look perfect either. Okay, so domain is all real. Range, this lowest value here is at negative 4. And again, my graph sits above it, so y is greater than or equal to negative 4. Okay. Alright, all of those have been greater than or equal to. Darn. Let's do 5 also, just so you can see a negative 1. Okay. Sorry. Just let me make sure you see enough. Okay? So we're going to have the negative absolute value of x plus 1. Okay? We got to find the vertex first. So we'll set the inside equal to 0. X equals negative 1. That's what I'm going to center the graph around. Okay, and then I'm going to go to add 1 each time, subtract 1 each time. So it'll be 0, 1, 2. Then negative 2, negative 3, negative 4. Awesome. Okay. So we'll plug these in. So for negative 4, just in case, I mean, it's pretty straightforward, but if you don't know what I'm doing, I'm plugging in the value for x. So I'm getting negative absolute value of negative 4 plus 1, which is negative absolute value of negative 3 plus 1, negative absolute value of negative 2, that's negative 2. Okay? Then I would do the same thing for negative 3. The absolute value of negative 3 plus 1 is the absolute value of negative 2. Wait, what? Did I do that wrong? I don't know why I did that. So this is negative 4 plus 1. I don't know why I wrote it twice. That's negative 3. And then I get negative 3. Okay, there. That makes sense now. Okay, then if I plug in negative 3, I'll get negative 3 plus 1. That's negative absolute value of negative 2, which is negative 2. And then we'll have negative 1. If I plug in negative 1, I'll get negative absolute value of 0, which is 0. And then you can see I'll have 1, negative 2, and then if I plug in 2, negative 3. Okay? So I'm plugging those in for x each time. Use your calculator. Do it over and over and over. It doesn't have to be too hard. Just punch it in, press equals. So let's plot these points. Negative 4 and negative 3. Negative 3, negative 2. Negative 2, negative 1, negative 1, 0, 0, negative 1, 1, negative 2, 2, negative 3. Okay, so this is actually going upside down, and the reason for that is because it's negative in front. It turned it upside down. So the domain is all real, of course, left and right, but the range, our value here is 0, and now the graph sits below it, so that's y is less than or equal to 0 now. Okay? Alright, good. That was an example of flipped over, upside down. Okay, let's do piecewise function 7. So we're going to have a line on one side, like we were doing before, the lesson before, and now an absolute value on the other, okay? So we're going to split the graph at negative 4. Do that first. Excuse me, positive 4. Positive 4. And then on the left side, we're going to have y equals negative 2x plus 1. We're going to graph that using m of negative 2 and a b of 1. Then on the other side, I'm going to have absolute value of x minus 3, which we're going to do at xy table. I'm probably going to do it on the side. Okay, the top one gets an open circle when it hits the line, and the bottom one gets a closed circle. So let's go ahead and graph y equals negative 2x plus 1, since we know how to graph that. And then I'll do an xy chart for the absolute value. Since that's new, I'll do that on the side. Alright, so let's graph the line first. So I'm going to have an m of negative 2 over 1 and a b of 1. And when I hit this line, I'm going to have an open circle. So that goes b of 1. Then we go down to right one, down to right one, down to right one. And when I hit the line, I have to do open circle. Because this says less than, not less than or equal to. So whenever I'm at x is less than 4, I have this line. Okay? Now, at 7, we're going to see these points and plot them, but we're only going to connect them on the right side of 4. Okay? So my vertex, when you do x minus 3 equals 0, x is 3. So I'm going to center my table around 3. Okay? If you're doing these on your own, hopefully if you just do a couple of points, it'll help. But this one we don't even look at it until 4. So we're really going to need to go up to 6, up to even 7 if you want. Okay? Alright. 0. Here's my vertex. Okay, so when I plug in 0, sorry, I was just centering it, so I went 3 below and 3 above, 3. So I hit off my little XY chart a little bit. That's all that happened. So if I plug in 0, 0 minus 3 is negative 3. Absolute value of that is 3. 1 minus 3 is negative 2. Absolute value of that is 2. 2 minus 3 is negative 1. Absolute value of negative 1 is 1. 3 minus 3 is 0. 4 minus 3 is 1. 2, 3. Okay? So I just did what we did before, except for we're only going to have it exist on this side of 4. Okay? So let's plot the points, but we're only going to connect them over here. Let me get a different color. Okay. And then when we hit the line, we're going to do a closed circle, because this is greater than or equal to 4. Alright, so let's go 1, 2, 2, 1, 3, 0, 4, 1, and I hit the line, so I'm going to put a closed circle, 5, 2, and then 3, and it would keep going. So I'm only going to connect it on the right side, okay? So yes, this is an absolute value, and it should be a V, however, it only existed when it was greater than 4. So now it just looks like a line, okay? Domain is all real, and range, our lowest value here, negative 1, 2, 3, 4, 5, 6, 7. And we have an open circle at that value, so y is greater than negative 7. Okay, because negative 7 was the lowest value, and it goes up from there. And it's an open circle. Alright, I know this is a lot of notes, but let's do number 8, last one. Just because we probably need a little more help with piecewise. So we're going to split the graph at negative 3 to 2, and 2. So go to negative 3 on the x and split your graph. And then go to 2 on the x and split your graph. Okay? So on the left side of negative 3, we're going to have the absolute value of 2x minus 4, and then we'll give it a closed circle because it equals 2. Alright, then I'll have negative 5 here. Let me do a different color. Negative 5. And then I have, they're both open, so I'll give open, open. Because I'm going to hit 2 borders there, not just 1. And then x is greater than or equal to 2. We're going to have x minus 2. And I'll give that a closed circle. Alright, so I'm going to graph negative 5 and x minus 2. And then I'll do the xy chart for the last one last. or for the first one last, okay? So for negative 5, we have ahoy, y equals negative 5. 1, 2, 3, 4, 5. And we're going to cut across, but it tells me to do open circles on both sides, or when I hit both borders. That's y equals negative 5. Okay? Y equals x minus 2 is 1x minus 2. That's a b of negative 2 and an m of 1 over 1. Okay? So again, I'm just going to connect the dots on the right side of 2. So we're at a b of negative 2 and a slope of 1 over 1. Up 1 over 1, up 1 over 1. And when I hit the line, I'm going to do a closed circle. Up 1 over 1, so on and so forth. Okay? Here is that line. And again, I really should be drawing the arrows every time. But especially with piecewise, I like drawing them. So it shows it's going off forever. Alright, last one is we need to make an XY chart for absolute value of 2x minus 4. Okay? So if you do the vertex, 2x equals 0, x equals 0, that's what we're going to center the graph around. And I'll go up to 1, 2, 3, negative 1, negative 2, negative 3. So I'm going to take the absolute value of 2 times the x and then subtract 4. Alright, so for negative 3, I'll have 2 times negative 3 is negative 6. The absolute value of that is 6. 6 minus 4 is 2. So 2 times negative 2 is 4. Negative 4. So the absolute value of negative 4 is 4. 4 minus 4 is 0. 2 times negative 1 is negative 2. The absolute value of negative 2 is 2. 2 minus 4 is negative 2. Okay, then I have 0 minus 4, negative 4. 2 minus 4, negative 2. Sorry. 2 minus... Sorry, 4 minus 4 is 0. Cool. And then 6 minus 4 is 2. Okay, so there's my whole XY chart. Then, I'm going to plot these points, but only connect them when they exist over here, on the left side of negative 3. Oh gosh. Which is the only side we saw. Okay. Alright, so negative 3, 2 is right here and it needs a closed circle. So I only did in my XY chart the right side of negative 3. Oh my goodness. So we're going to have to find some more points. Oh my gosh, I can't believe I didn't realize that. Okay, that's okay. So we're going to have to find some more points because that doesn't help me. I only have the right side. I don't have the left side. I guess you could plot them and use symmetry, but that's okay. So we'll have negative 3, negative 4, negative 5, negative 6. And so that will give me points to connect over here. Alright, try it again. So negative 6 times 2 is negative 12. The absolute value of that is 12. 12 minus 4 is 8. Negative 5 times 2 is negative 10. The absolute value of that is 10. 10 minus 4 is 6. Negative 4 times 2 is negative 8. The absolute value of that is 8. 8 minus 4 is 4. Negative 3 times 2 is negative 6. We already did that. So 6 minus 4 is 2. There we go. Okay. Alright, so now we'll plot the left side. So negative 4, 4. Negative 5, 6. And negative 6, 8. There we go. Alright, that's our piecewise function. Okay, domain is all real. Oh gosh. Alright, the range is y equals negative 5 union, there's a whole gap right here. So this gap we can't include, but then the rest is good. We have 0 and then we're going up from there. So union y is greater than or equal to 0. That is the range there. Okay? That's it. You have just 6 questions for homework. Alright.